normal values real soon. That's all I got. Thanks.
Thanks, Todd. Bye, Todd.
All right, take it away, guys. All right. Good morning, everyone. I'm Greg Hankins with Force 10.
Chris Malater with Switch and Data.
And we're going to talk about 32-bit ASNs, which I think is a pretty relevant and pertinent topic now these days. A little bit about terminology. Unfortunately, there's quite a bit of terminology out there already for this new technology. So basically, we would just want to let you know that we're going to standardize on using kind of the ARIN terminology, which I think is pretty good. We're going to talk about 16-bit and 32-bit ASNs, even though other things mean the same thing.
All right, the background for this, we're presently running out of 16-bit ASNs. From our research, the first IR to run out of 16-bit ASNs will occur June 4th of 2011. That's a moving time, so it goes up, it goes down, but somewhere in the middle of 2011 is where we're looking. So we need to increase the number of ASNs. 16-bit, 32-bit, lots of 32 bits. I can't imagine peering with a 4 million ASN, but it could happen. So 32-bit ASNs will affect everyone, even if you still have a legacy 16-bit ASN. So this is the schedule, 2007, 2008. You could get 32-bit ASNs, but 16 bits to default. Right now, again, 32 is the default presently, but most people are still opting in for the 16-bit ASNs. January 1st, 2010, no distinction, 32-bit only. The rest of the 16-bit ASNs will be reserved. You can see the table of allocated 32-bit ASNs from what we have and then what's advertised to date. Okay. So lots of questions for ARIN about the policy for changing it so that they don't default allocate 32-bit ASNs and reserve it. But as of yet, nobody's actually submitted a policy change to have it extended. So right now, January 1st, 2010 is pretty much the hard date. ARIN always asks if you want the 32-bit ASN. Most people, say, once they figure out what's going on, say, no, 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 no. We want the 16-bit ASN. So since 2007, 169 requests for 32 bits. All but 7 of them have changed back to 16-bit ASNs. 7 32-bit ASNs from ARIN have been allocated. As of January, 3 32-bit ASNs have been requested, all changed back to 16-bit ASNs, and no new 32-bit ASNs have been issued this year. So, the operational issues. It's actually, the operational issues are huge here. If you don't like seeing 2, 3, 4, 5, 6, which Greg will talk about in a little bit in your AS path quite frequently, 32-bit ASN supporting hardware and software is going to be really, really important. Pretty much anything that you can think of related to, the internet, equipment, software, whatever, is all going to be affected by this change. Especially, the most important, obviously, is the routers, the routing software that support and understand 32-bit ASNs so that you don't get the compatibility mode in your AS path. Routing policies, peering policies, when you talk about the routing policies, communities are going to be a huge one that's going to come up. When Greg's going to get into a lot about the technical issues of the format of 32-bit ASNs and how this is really going to affect communities, route maps, policies, everything on your platforms. This is a huge deal. Training for your staff, to understand different syntaxes on different platforms of the 32-bit ASN format is going to be pretty big. Management tools that are hard-coded to 16-bit, might not support different formats of the 32-bit notation. That's going to be huge. Monitoring tools, even the sales staff. If you don't support 32-bit ASN customer connections, just by default, and you're still running a compatibility mode, that's going to be a huge deal if the customer is connected in multiple places to you and using meds. So knowing what your sales staff can sell people is going to be a big deal, especially if they promise something that you can't deliver. So.
Okay, we're going to briefly talk about the design goals and a little bit about how it works. There are a whole bunch of other presentations which we have as a reference in the back which go into more detail. So we'll just kind of cover it briefly here. But basically, there's a new RFC 4893. Introduces a new capability it's called AS4. And there are two new optional transitive attributes. Now, in case you forget about the intricacies of BGP attributes, optional transitive basically means if I don't understand it, then I just pass it along and I don't do anything with it. So that's one of the things that enables compatibility, because this new AS4 path will just be passed along transparently by routers that don't understand it. There's a compatibility mode, which we'll talk about in the next slide, between 32 and 16-bit implementations. And then there's also a native 32-bit mode between 32-bit peers. And the goal was really a gentle transition and incremental deployment. And the point that I want to make is that there are several prefixes that have been advertised with 32-bit AS numbers for quite some time, and you probably didn't even notice, unless you were Andy Davidson. So this is what it looks like. Remember AS23456, you're going to see that over and over and over again. This is a valid reserved AS. It's reserved for the transition between 32 and 16-bit AS numbers. It's used to represent a 32-bit AS number every time it occurs on routers that only understand 16-bit AS numbers. It's not a bogon. So you're going to see it in the AS path, and also if it's peering in compatibility mode, the 16-bit router will actually peer with AS number 23456. So here's output from a router that actually doesn't understand 32-bit AS numbers, and you can see the 23456 in the AS path, and then you can also see the optional transitive attributes, which is the AS4 path. So it doesn't know what that is, it just knows that there's an attribute there that it needs to pass along. Here's another example, two views of the same prefix. The top router doesn't understand it, the bottom router does understand 32-bit AS numbers and can actually put the right AS number in the output. So here's a little bit about compatibility, and this is my stunning PowerPoint animation. Okay, let me set the scene for you. I use obvious numbers, so the AS numbers in 100,000 are 32-bit AS numbers in 65,000 are 16-bit AS numbers running on routers that only understand 16-bit AS numbers. Okay. So this router starts to advertise a prefix with an AS path of 100,000, right? That seems pretty straightforward. Talking to another router that understands 32-bit AS numbers, so they peer natively with 100,000 and 131,000 as the AS numbers. And then along comes this router, 65,000, that actually doesn't understand 32-bit AS numbers. So this router is going to peer with AS23456 instead of 131,000 in this diagram, because he can't actually understand 131,000 as the AS number. So because the router AS131,000 knows that it's running in compatibility mode, it's actually going to put in a 16-bit AS path along with the 32-bit AS path. And he's going to translate the AS numbers into 23456. So you start to see, again, there's a lot of 23456 in this diagram. Okay, peering between two 16-bit AS number routers, nothing really changes. 65,000 just puts in its AS path at the beginning and sends it along the way. Now you see that there's starting to be a difference between the 16-bit and the 32-bit AS paths, because, again, an optional transitive attribute, router in AS65000 doesn't understand it. It's just going to pass it along, and it can't understand it, and it doesn't modify it. Again, peering between routers 65,200 and 121,000, the peer AS is going to be 23456 again, because router 65,200 can't actually understand 32-bit AS numbers. And it sends the AS path along the way. And then what the final router here in AS 121,000 has to do is reconstruct and merge the AS path so that it comes out correctly. So you see he's going to take the 16-bit AS path and then merge in the 32-bit numbers, and out comes the correct AS path. Okay, so again, key points to take away here are that if a router is peering in compatibility mode, it's going to peer with AS23456. So a little bit about notations. There's a lot of notation that has been proposed. The ones that have been widely adopted and implemented are AS plain and AS dot, and here's a couple of examples of how each notation would look. RFC 5396 just came out in December, and that recommends to use AS plane as the notation. I have a couple other slides on notation we'll talk about a little bit, but it's going to be confusing, unfortunately, for a little bit because AS plane and AS dot are so widely implemented and already deployed that we're going to have to use both for a while. Here's a little bit about notation. I apologize for the denseness and the fact that this slide is unreadable if you're in the back, but I wanted to put all the arguments on the same slide. So as I said, RFC 5396 just came out about 6 weeks ago. It recommends AS plane as the notation. Operators love it. AS plane is also compatible with existing AS path regular expressions, so if you use an AS number which has a dot in it, that actually interferes with AS path matching, so regular expression matching. So you'd have to rewrite all your regular expressions to escape the dot in the AS number now, and then that's going to be a lot of difficulty. I run a router with 5 policies, and I had to rewrite mine, and it took me probably 30 minutes, so I can't imagine an operator running a router with hundreds or thousands of policies that you have to rewrite and test and validate. There's also a couple other things. SNMP has a problem with ASNs that have dots in them. AS dot could be interpreted as a floating point number in some cases, and it just causes many operational issues. So IANA was using AS dot, and they've switched to AS plane now, and all of the RIRs are currently using AS dot, but have plans to transition to AS plane at some point in the future. Now, there is a good argument for AS dot, is that it is a little easier to remember, and the way that the AS numbers have been allocated, you can see it's really clean if you're using AS dot, because you know that 2.0 is apneic and 3.0 is ripe, and so on and so on. So again, you need to start liking this AS number 23456 a lot. I'm starting to get tired of saying it in the presentation, honestly. But basically, as we said, everything in your network is going to have to be upgraded. And again, since 23456 is used to represent every 32-bit AS number, it's impossible to know the real AS number of the prefix. So the implications are many, and it's going to make it operationally very confusing, because you could peer with AS number 23456, which represent, again, different 32-bit AS numbers. You could possibly peer with them multiple times in different locations. You're going to see 23456 everywhere in the AS path. It causes difficulties with routing policies, as we kind of alluded to. Communities is kind of an open discussion issue right now, and obviously you can't match on a 32-bit AS number if your router doesn't understand them. MEDs are going to become interesting. Think about best path selection between different ASs. MEDs aren't used unless you enable it, but if you're peering with AS 23456 now, all of a sudden that's the same AS number, even though it represents different ASs. So MEDs could be used to determine the best path, and then all your flow data is going to have a lot of 23456 in it if you're using flows with AS numbers for NetFlow or SFlow. So here's kind of an example of a couple different prefixes, and then what it would look like on different routers that understand and don't understand 32-bit AS numbers. So you can see the second prefix, for example, 23456 appears in the first AS number in the AS path, and then also in the middle. So if you're looking at that on a router that doesn't understand 32-bit AS numbers, it kind of gets confusing, because you don't know if that prefix is being transited or originated or what by AS number 23456. And then imagine this kind of scaling up. You know, right now I think there's maybe 15 to 20 prefixes that are being originated from 32-bit AS numbers, but imagine if that starts to get into hundreds or thousands, it's going to become pretty unmanageable.
All right, so software support for 32-bit ASNs. There's a wide and lots of different implementations, what's supported, what's not, and when it will actually be supported. We're not going to go over this vendor by vendor, but take a look for your vendor, and you can see where it's at and what's planned. Tools for supporting 32-bit ASNs. This is going to be, we're going to see a lot. There's not a lot out there right now. There's some, but you're going to start to see more and more as people catch on that 32-bit ASNs are there. The IRD already accepts it. RIR, who accepts it, and NetFlow v9 and SFlow v5 support it. But again, the router needs to fill in the 32-bit ASN to get the SFlow, so that's going to be the catch there. Missing support. There's, as we've said over and over, there's a lot of stuff out there that doesn't support it. Looking glasses, trace route servers, route servers, route view servers, tons of stuff that does not yet support this. I think that we're going to have, for operators and such that have looking glasses and stuff out there, I think this is going to be a unique experience to look back at somebody that set up the looking glass 10 years ago to go back and fix it to support 32-bit ASNs, or to completely redo your looking glass at this point in time. But so for the peering DB people, hopefully sooner than later we'll be supporting 32-bit ASNs. Known operational issues. Remove private AS command only works on 16-bit ASNs. Are you going to deal with this?
Yes.
Okay.
So remember, since the RFC just came out on 32-bit AS numbers, assignments and notation, right now you expect remove private AS to strip off AS numbers, but it's actually not going to do the 32-bit AS numbers, which are now private. There's an interesting article as a reference here. By the way, when you download the PDF, I think all these should appear as hyperlinks so that you can just copy them or click on them. But there could be some routing loops and strangeness. Again, this presentation from Cisco has a really good example of how med usage changes and best path selection changes if you're peering with multiple ASs that are represented by 2, 3, 4, 5, 6. And as we kind of talked about, unfortunately, we have this mixture of notation now. So while everyone wants to move to AS plane, there's so much AS dot out there that we're going to have to deal with it for a while, probably until everything supports AS plane, and then a lot longer, because once something's out there, it's just really hard to get rid of, unfortunately. Let's talk about communities a little bit. So RFC 4893 actually refers to this very exciting internet draft. However, it's on a -2 revision, and virtually nothing has implemented it so far. Someone told me that Quagga supported it. I haven't actually checked that out. The other interesting thing is that the format is a 32-bit integer followed by a 16-bit integer, so you actually can't set the local administrator field to be your 32-bit AS numbers. This breaks the filtering convention that's used at a lot of internet exchanges around the world, so this could be a problem. And honestly, there's no really best common practice or recommendation on how to use communities right now, because it's just kind of still up in the air and under development. So as this draft matures, hopefully you will ask your equipment vendor to start implementing it. Okay, so this slide is interesting. Andy was talking about this yesterday in his lightning talk, so I'll refer you to that, to all the details. Also to a very nice mail to the NANOG mailing list sent by Rob. I noticed the same thing. I think Andy said December 10th. I noticed it around Christmas for some time because I was logging into a router. But I saw 3 prefixes with AS number 23456 in them, and I thought, wait a minute, my router understands 32-bit AS numbers, so why would it ever see 23456? Because it knows how to translate them, right? So what's actually happening is someone is sticking 23456 in the AS path. So I talked to, you'll notice 19151 appears in there and directly appears with this AS 35320. I talked to Randy, and what he was actually seeing on his peering connection already had the bad AS path in there. So there's no real way to know what's going on inside AS 35320, and they haven't been very responsive when we tried to contact them. I've sent a mail. Andy and Rob have sent a mail, and they just don't answer. So until we actually hear from them on what's going on inside their AS, we really don't have any idea. All right.
So to test 32-bit compatibility mode or 32-bit native mode, we've set up a temporary peering router in PAX Palo Alto to do multi-hop peering. So you can connect to it. You send us email, we'll set it up, and you'll see our announcements. And if you want to announce stuff to us, we'll see your announcements. You can log in to the server, just like you can at route views, to see what the output is coming back from your equipment. so you know if your equipment is compatible as well as working the way that your equipment vendor says that it should work. Sometimes that's not always the case. So we will peer with you gladly, openly, as many routers as you want, as often as you want. But it's there for your use, and we've already had some people that have tried it and liked it, so hopefully you will like it as well. What should you do? Excellent. You know, awareness is the number one thing, and so that's why we're here. And we're hoping that you take the awareness that we're bringing to you, or that you already have, and go talk to other operators and let them know that this is going on. Know what the impact's going to be to your network, your equipment, your support staff, your overall impact of this. Ask your vendors, beat on your vendors to implement 32-bit ASN support, specifically AX Plane. And for vendors that already have implemented 32-bit ASN support, buy them a beer. Develop an upgrade plan, test your stuff, get it upgraded, and start running native 32-bit ASN.
Okay, so a couple conclusions. The internet is going to keep running, and as will your network. Two big changes are if you have a 16-bit AS number a day, you should really look into upgrading real soon now. And then remember, you'll see 32-bit AS numbers appear as AS23456. So we were kind of speculating on how many people were logging into their routers right now doing a show IP BGP regeps 23456. So I imagine that a number of you have done that, and you're probably surprised at how many prefixes are out there. If you don't have an ASN today, then you'll probably be getting a 32-bit AS number real soon in the future, unless you explicitly ask for a 16-bit number. And you'll need to upgrade as well. Here are a bunch of resources, and I apologize, these are kind of hard to read, but basically a couple of things I want to point out is that there are a lot of interesting RFCs, there are a lot of interesting presentations that go into more detail. As I said, Jeff Houston does a lot of very interesting tracking on utilization, and we've also been working on a wiki with much more information than is in this presentation, so I kind of like to refer everyone to that one. That'll have the latest versions of the software support, as well as links to everything that I can find, and hopefully more of an introduction as someone, hopefully not me, signs up and starts to write stuff for it. Like I said, it's wiki, so anyone can log in, create an account. The other interesting thing is, like, man, all this notation is confusing. How do I convert between them? Well, I was using DC and some, hex to decimal conversions and things like that, because I can't do this kind of stuff in my head. And then turns out there's actually a nice Perl module out there for converting notations. So I would encourage everyone to download that one and then use that Perl tool to convert between 16-bit and 32-bit AS numbers as you need to. And then lastly, some thanks to everyone that's reviewed and contributed. Like we said, talk to other peers, talk to your friends and equipment vendors and see what they're doing and seeing what they're supporting. And also special thanks to Switch and Data for hosting the S4 peering router for their contribution to that. And that's it. Any questions, comments?
Hey, Dave, over here.
Hi, Dave.
Hi. Hey, a couple things on the route view side. Okay, iOS doesn't support 4-byte ASNs. We're trying. We route views are trying. I don't know why the iOS guys are dragging their feet on that. We've tried. We continue to try. Hopefully we'll get it. Number one. Number two, what do you guys think about, I don't know how many people here have routers that are talking with 4-byte ASNs, but we have this like experiment, this Lisp network thing. Anyway, the Lisp network thing, we started off with AS dot notation and the implementation we were using, and it went to AS Plane. And AS Plane is really tough to deal with, like when you say show IP BGP, what AS is that? And do you guys have any idea of how we're going to deal with that?
I don't know.
You know what I'm talking about?
Yeah, even just talking about it, like in my examples, like AS number 131, whatever thousand, I can't imagine being the guy that goes to the peering BOF and stands up and says, my AS number is, 2,326,000, whatever. But I don't know.
Operationally, it's kind of a nightmare, right? That's what I'm trying to say.
But operationally, I think AS dot is more of a nightmare, so maybe it's like
it's more of a nightmare with respect to all the things you listed off. It's like, well, dot is a regular expression, meta character. Maybe we should put that in the, that stuff. But on the other hand, AS.'s a lot nicer to look at.
Yeah,
True.
agreed.
Hey Greg, I have a contact at Eurotrans Telecom, AS35320, and it happens to know they also have a looking glass. So if you want to find me afterwards, I can put you in touch, but it looks like they're running Junos and they're running Confeds, and there's something strange going on to produce that.
Okay.
thing.
Thanks, I'll find you. Rez?
So the only response that I can come up with whenever people say, well, how will we remember all these numbers? Anyone that watches The Simpsons knows there was an episode on this for the area code splits where they're playing the clip from the phone company and they say, well, how will I remember all these numbers? And the answer is, scientists have shown that even monkeys can remember 10 numbers. You're not stupider than a monkey, are you?
Well, just one comment regarding AS dot. If it is more convenient for use, were there some ideas to use some other character as separator?
That's a good question. I haven't followed the discussion on notation on the IDR mailing list and in the ITF very closely. I'm not sure why dot was chosen as a separator. There was one vendor that uses colon, which is kind of equally confusing because communities already use colon.
Well, I might have an idea because the old DECnet Phase 4 protocol used dot between area and host ID. Now, maybe someone came to the same idea. But yeah, dots are inconvenient. I would say AS plain, yes, it is difficult to see it in show IP BGP. But on the other hand, tools and regular expressions will break. So if we have to choose between tools that are really important for us operationally and let's say look and feel, I would rather choose for stable tools than for look and feel. And look and feel we can switch with an option within the implementation like show IP BGP, AS dot, and then I get an overview in AS dot. Is that an option?
It's possible. There are a number of vendors out there that support different notations. In some cases, it's a configuration command. There's actually a patch for Quagga that does exactly what you're talking about, where it just accepts the AS number in any format, and then you can use whatever you want. So maybe that's a direction that you can ask your vendors to go.
I think it doesn't really matter what special character you put in there. It's still going to be a nightmare for the regular expressions.
Yeah, but I mean, certainly there's some flexibility that we as router vendors could put in there on the CLI parser that can figure out what format the AS number is.
Sandy Murphy, Sparta. A couple of security comments. The CIDR working group in the IETF is working hard to provably state who is allowed to announce the origin of a particular prefix. And with this, 23456 is going to look like it's announcing a whole lot of prefixes, and any 4-byte AS will be able to do prefix hijacks on any other 4-byte AS, even with very strong RPKI. Yeah, oh well. I don't know how those IRRs that use the RPSS security system are going to deal with this. RIPE is an example. The route object is supposed to be attested to by the prefix holder and the AS holder. Who's going to attest for 23456? They'll probably
Absolutely.
have to have a, anybody gets to say 23456 originates this. A couple of people asked me last night what comment I was going to make at the mic after Andy's presentation, so I thought I'd choose this opportunity since you mentioned his presentation. He was focused on changes to the spec that would permit the one implementation bug that produced failures someplace else in the system. That's not the only possible implementation bug that would produce that. Any ill-formedness in that attribute would cause problems. So just that one fix isn't sufficient. Also, any optional transitive attribute that is not fully deployed everywhere will cause the same problem. And I know of at least 2 other drafts in the IETF that have proposed optional transitive attributes that will run into the same problem. It's a design problem in BGP itself. Okay?
And also the fact that anyone could just put 2, 3, 4, 5, 6 in using a route map or some sort of routing policy.
Yeah.
They could just stick it in the AS path anywhere they want, really.
And people can put any AS in the AS path they want, which is an interesting feature.
It's just a minor, insignificant nit, but why would anybody care about 32-bit privates? I mean, other than the fact that somebody somewhere is probably going to turn it on and maybe just for symmetry or something, but, you know.
Same reason you'd use 16-bit privates for testing, internally.
Well, I mean, there's a lot of 16-bit privates out there being used, but I guess
Sure.
somebody somewhere is just going to turn it on and
Yeah,
use
I mean,
it.
customers that
Yeah.
can't get a real AS number for whatever reason.
But, I mean, you could always use a 16-bit private no matter what, right? So,
Sure.
yeah.
But also for, there's a number of ASs that are reserved for documentation
Yeah.
and things like that.
Yeah, there's some stuff.
Okay, Louis?
Hey, thanks. Louis Lee, Equinix, also NRO Number Council. Is anybody familiar with some kind of lookup system where you type in a name and a number gets spit back out to you? I'm not advocating that we use DNS, but maybe if people would register their new 32-bit addresses in the IRRs, then maybe we'll start getting introductions. Say, I'm Louis from AS-Equinix-22, rather than this huge number. It's a lot easier to remember, right?
Okay, thanks.
Thanks, Chris and Greg.